Okay, continuing example 7. So we just used synthetic division, right? And this is what we got after we divided by our root 2. So maybe let's write that down. One of our roots is 2. So let's keep that in mind. And this is great. We are happy because now that we, and well, let me say one thing real quick. If you multiply this out, right, if you double distribute, you should get the polynomial that we're working with. If you don't, then, okay, there's an error, or maybe we factored incorrectly. But if you multiply it out, it actually works out. If you don't believe me, please multiply it out to prove to yourself that it does actually work. But this is great because we love quadratic polynomials because we can factor them, we can complete the square, if you remember how to complete the square, we can use the quadratic formula. Especially the quadratic formula. So we already know, and actually, I just noticed that should be a 2. So let's use the quadratic formula for this. R equals, so negative b plus or minus the square root of b squared, which is 4, minus 4 AC, so that's 1, and IC is 5, all over 2a, or 2. All right, and then we have 4 minus 20 all over 2. And then we have negative 2 plus or minus the square root of negative 16. Okay, so I know we're going to get an imaginary root because of that. That's going to be an imaginary number, right? This guy, remember, is really the square root of negative 1 times the square root of 16. Well, that just gives us negative 2 plus or minus, so that's going to be 4i. Right, there's our imaginary part. So this is very hard to factor because we get an imaginary root. So over 2, and, well, could have just done one more step, but this is really negative 2 over 2 plus or minus 4i over 2. And this is a big 1. So negative 1 plus or minus 2i. Okay, there's my a, and there's my b, right? Remember, a complex number is in the form, a complex, that should be number, whoops, okay, that's just a complex number, is in the form a plus bi, right, where b and I are real numbers. Okay, so here, let me just write it out. A is negative 1, and b is 2. Okay, so now we have our 3 roots, right? Or one of, well, here's our, let me write it down, complex conjugate pairs, right? That's what we call them in algebra, right? One of them is negative 1 plus 2i, the other one is negative 1 minus 2i. And let's see, the book calls it, I'm assuming, R2 and R3. Well, okay, let's just write it like this. Okay, so now let's put everything together. So remember, our first root was, I believe, was 2. So R is 2. Let me actually write it in words. Okay, so what roots did we find? Okay, one of them was 2. The next one was negative 1 plus 2i, and the other one was negative 1 minus 2i. Okay, so now let's use our theorems that we know, and again, depending on the form it's in. So one of them is 2, right? That's just a regular, there's no double root, it's not complex, no pun intended, but no complex, right, imaginary numbers for 2. So we can write, right, this guy is really, so let's start writing it out. Y of x equals C1 e to the r, usually we call it R1 of x, right, because it's our first one. So this is e to the 2 x, Okay, so that's done, but we still need to fill in, right, another part. Well, that other part is going to come from, and we get, I don't know, it's purple maybe, right, is going to come from these two complex roots. So what's the theorem? So I'm looking at your book, complex root. We're going to use, to find these guys, we're going to use theorem 3 in your book, page 131. And I did a complex root problem earlier, so hopefully that helped. Whoops. Okay, so we have, well, let's see, what's our -1 plus or 2i? So let me write it in maybe purple so we know we're only working with that one. Okay, so we have e to the ax times the quantity c1 cosine bx plus c2 sine bx. Okay, well, what's our a and what's our b? Okay, e to the ax. What's my a? My a is -1, right? Here's my a and b. So negative x, right, or -1x, c1 cosine bx. So my b is 2, so 2x plus c2 sine 2x. And that's, basically it. If you want to, it doesn't hurt to write, right, this is really, okay, R1, right, because that's the first one we found, right, was really that guy. R2 was really that guy, and R3 was really that guy. If you really wanted to call this R2 and R3 or switch, it really doesn't matter. But, oh, actually, let's put this all together, the final answer. Y of x equals, okay, first root was this guy right here. C1 e to the 2x plus, and might as well write in purple, e to the -x times c1 cosine 2x plus c2 sine 2x. So this is our final solution. And that's it. So yeah, the book skipped just quite a few steps, but hopefully that helps just fill in any gaps. Again, if you need to review in synthetic division, go back to your algebra 1 book, go to YouTube, Google synthetic division, and there's a ton again of great open educational resources out there. If you want me to just practice a couple more, you can let me know as well, and I'd be more than happy to do that. Okay, so I'll stop here.